Welcome, dear learners. Let us look at reflection of water waves. Here are the outcomes, the learning outcomes of this lesson. You must be able to describe the reflection in water, demonstrate the understanding of water waves to show reflection at a plane surface. When we're doing reflection, we will use the ripple tank to study the reflection of water waves. Small amount of water is poured on a tray. So here we have a ripple tank. So this is the ripple tank. The small amount of water is being poured on the tray. So here is the tray. So on this tray, it is where we pour small amount of water. A straight barrier is placed at the angle or to the upcoming rays. So here is a barrier. So you see this small object is the barrier, and here this bar generates waves by the use of the motor that is attached to the bar, so that it causes it to vibrate. The behavior of the waves is studied by viewing the image of the waves on the screen. So you remember that there is a light bulb here. So there is a light bulb here which shines over the water, and then there is going to be reflection, or there's going to be images that are going to form on the screen. So this is the screen. Okay. So wave production and the ripple tank. Reflection of waves. A straight barrier standing upright in the water wave causes the incoming waves to be reflected. So you see this barrier that we talked about here. It is going to cause the waves to be reflected. Now here are the waves, the upcoming waves. So we use wavefront to show the upcoming waves. So these are the upcoming waves. We show them here. So these are the wavefronts that shows the upcoming waves. Now, when those waves hit on the barrier, which is this barrier, so this is a magnification of what is in the ripple tank. So this whole thing is just a magnification of what is in the ripple tank. So this barrier now is going to cause the water waves to be reflected. So that now we have the water. So these are the upcoming wave fronts. So you can see the upcoming wave front. And then what is going to happen is that they are going to be reflected. So let me use a different color to show the reflected waves. So here are the reflected waves. So they are reflected to this direction, as shown by that arrow there. So these are the reflected waves. Sorry, reflected, not refracted. I'm very sorry for that one. These are the reflected wavefronts. So you should note that a straight barrier is going to cause the incoming waves to be reflected. So it is placed at an angle to the straight waves that are coming. So we place the barrier at an angle. So this is what you will see on the screen. So this is the diagram seen on the screen, images of waves as seen on the screen. So these are the incoming waves. So you see the waves, they are incoming, so we can draw a wave, a ray diagram, a ray here to show the waves. So you should remember that when you are drawing the wavefront and the ray should be perpendicular. So these are the waves. So it is 90 degrees, this thing. All right. So, and it hits the barrier. So this is the barrier that is put in the water, and then it is going to cause a reflection. So this one is going to obey the law of reflection as in light. So what do we mean by obeying the law of reflection? Is that here we will have an imaginary ray, so which we call the normal. So here we have the normal. So let me just draw it again. So here we have the normal. So the normal is just an imaginary ray which is drawn perpendicular to the barrier, and yes, it is where the two rays, the incident, so this is the incident, ray, and this is the reflected, sorry for the reflected ray. So this is I and this is R. So I is equals to R, as you know, the law of reflection. So these are the waves. Even the other one shows a simplified diagram. So when waves hit hit an object such as a barrier, they can be reflected. So we have just mentioned that. And when waves are reflected, when waves are reflected, this one is supposed to be reflected. Angle of incidence is equal to angle of reflection, which I is equal to R. During reflection, the following remain constant. The speed of the wave doesn't change. So the speed of these waves in the incident waves is equal to the speed of the reflected, is equal to the speed of the reflected waves. Also, the frequency doesn't change because the frequency is determined by the motor. So here is the motor that generates the waves, these ones. Also, the wavelength is the same. So wavelength is measured between two wavefronts. So this is the wavelength. This distance, oh sorry, I'm unable to draw. So this is the distance is equals to one wavelength. So I hope if you have forgotten how we draw wavefront, so please go and look at the previous video. Okay, so examination tip: when drawing waves being reflected, take care to make sure that the angle of incidence is equal to the angle of reflection. Keep the wavelength of the wave the same. All right, so before I end this one, let me just use this space. So here we have a ripple tank. So this is a ripple tank. We are given an equation in an exam. And then here we have a barrier. This is a barrier in the ripple tank. And then here we have upcoming waves. We have upcoming waves. So you should note that the wavelengths, my wavelengths are equal. So I can just draw three wavefronts instead of drawing a lot so that it doesn't complicate my diagram. And then in the examination situation, they will ask you to continue to draw other three wavefronts shown after they have reached after touching the barrier. So what you can do here is just to draw a line through the center of this wavefront, which represent a ray. So this line, you should remember, it is 90 degrees to the wavefront. So it should be 90 degrees. So, however, you don't need to show that. And then you can draw the next thing you can do is to draw a normal. So the normal is 90 degrees to the barrier. So here I can draw a normal. I hope that one you can see. So which is 90 degrees to the barrier. And then what I do now, I measure this angle. And then this is I. So if I suppose it's 45 degrees, then I will measure another angle this side, which is going to be R, so that it is 45 degrees. So I measure this one so that it is 45 degrees. And then I draw the wavefront. So I can just draw three wavefront. So these three wavefront should be equal in wavelength. The distance between them, they should be equal. Okay. So I have gone through the exam tip. So this is the end of this video. Thank you.